Hello, everyone. Let's continue our talk about soil plasticity. First of all, I have to say it's so weird to talk into a camera or in front of a screen. I prefer having you in front of me, very much so. But uh, yeah, so a quick recap of all the discussion we had last time. We talked about the clay minerals. It's very interesting. That is, it can be remolded without crumbling. Uh, with a variation of moisture content, the clay specifically behaves very differently. As we can see the picture here, we have a very moldable clay uh, in a relatively in a in a plastic state versus the picture on the right clearly shows that it's almost in a liquid or a slurry state. And we talked about the dipolar character of water and how that play a role in forming something called a diffuse double layer DDL in clay minerals, and that uh, this cohesive nature of clay is caused by all those water or the water film surrounding the clay particles. We talked about different minerals. They have relatively different thickness compared with their um, diffuse double layer, and this can also tell some of the physical properties of this material, as in this mineral on the left clearly will show more plasticity compared with the soil or the clay mineral on the right. And we talked about some of the limits, part of the Edinburgh limits that are important for our practice. That is specifically PL, which separates the soil from the solid, semi-solid side to the plastic side, and the liquid limit, which separates the soil from the plastic side and the liquid side. And the soil at those three different states, solid on the left, uh, plastic in the middle, and the liquid on the right, they would have very different stress and strain diagrams. And then we talked about Edinburgh limit, Casagrande cup test. And you have all done this before. And we briefly talked about the reliability of this test or repeatability of this test. It's not really good. The definition is that we want this groove in the middle to close about half an inch after 25 blows, and we call the moisture content of the soil in that state to be the liquid limit. Again, we talked about it's pretty hard for you to just go one trial to get that number to be exactly 25. So in reality, we do multiple testing, we do a best fitting, and we'll try to find that 25 blows and then find the correspondence moisture content. And also talked about the plastic limit test, and some of you refer to this as the worm testing, which is pretty funny actually. Uh, that so basically you roll this soil into a worm or a little cylindrical shape, and if the soil just starts to crumble at a diameter of about eighth of an inch, call will have the moisture content of that soil at that state defined as the plastic limit. So the first definition out of the LL and PL is that the plasticity index or PI. Here I want to say we talked about the inconsistencies of unit and definitions across civil engineering. And also here is another example that specifically in geotech, though LL and PL both are moisture content. And we, in the previous chapter, we typically express moisture content in a percentage. So, but here we're still using the percentage, but we just get rid of the percentage sign. So, for example, if you get your LL to be, let's say, 45%, that's the moisture content, instead of using 45% as the liquid limit, we just use 45. Same thing, if you get the moisture content of that soil to be, let's say, 35% for their plastic limit, and then we're just going to use 35. So LL and PL here, it's all going to be, instead of percentage, it's just a number before the percentage. So 45, let's say 45 and 35, then your PI will be 10. So that's kind of, again, a little bit inconsistent, but hopefully that will be something you'll get used to pretty quickly. And based on the PI number, we can define the soil, whether it's a non-plastic. Basically, if your PI is 0, it's non-plastic all the way to over 40. That means the soil has a very high plasticity. We're going to talk more about this in the soil classification. There's another one called LI, or liquidity index. Not very, very popular. At least you won't really use this in soil classification, but some of the lab testing, they will report this number as well. The definition is pretty straightforward. You have omega, which is the moisture content of the soil in natural state, or sometimes I call it in situ state. Like, you get a soil sample from the field, you seal it up to make sure you won't lose any water, you take it back to the lab, you test it immediately. Or, as it's all sealed up pretty well, you don't really have to test immediately, but that's the moisture content. We're talking about that omega in situ moisture content right over here. And then you do the test for adequate limits. You get the PL, you get the LL, and everything. So you can define your LI over here. So LI should be a number that that is, it could be 0, it could be negative, it could be 1, it could be more than 1. So it really depends on where your soil is standing at. So that's LI. And there's another one called a plasticity chart. This chart, we will use this for our soil classification system. Basically, I want you to look at those two lines. There's one line called A line over here, and there's another line called a U line over here. So let's start with this A line. So A line is, of course, those lines are constructed based on so many years of research and having database from different type of soil, and it's kind of a generalized line for you to give you some idea of what kind of soil we're talking about. So essentially, everything below the A line, if you look at this over here, you're gonna have some silts and an organic clay or silts of high compressibility. So basically, things below the A line, they're all silts, and things above the A line, they're generally clays. And we're talking about mostly inorganic stuff over here because this is the soil that we're dealing with most of the time. And nothing technically should read above the U line. So U line is either, if something is above the U line, either something we haven't really seen or really haven't used a lot, or it could be indicating that some of the testing went wrong. So, okay, let's move on. So this is a practice problem, but we can't really do this together now. But this is kind of give you idea of um, how to process the data. Again, you might have done this before, but essentially this is the original data from a liquid limit test. You're gonna have the blow counts or number of blows. I shouldn't have said blow counts. Blow counts is specific for SPT testing, but you're gonna have the number of blows on the left, 15, 20, 28, and you have the corresponding moisture content, 42%, 40.8%, and 39.3%. So you should be able to construct a curve like this, basically have your moisture content on the y-axis and have your blows on the x-axis, and make sure you do your x-axis in log scale, and you do all those three lines and do the best fitting of those three dots, and then yeah, go find where that 25 is. 25 is right over here, and go up and go left and come up with your LL is 39.5% of moisture content. So this is from textbook, but technically this is not correct. We don't really do LL equals 39.5%. So make sure you got rid of that percentage sign. It is a moisture content in percentage, but again, the convention is we just use that number, 39.5 as your LL. So that's basically the liquid limit of this material. So again, inconsistencies. Sometimes you will see lab, most of the lab, decent lab, they will give you a LL like 39.5. They shouldn't include the percentage. But sometimes if you see some wacky results from some wacky labs, you should be able to understand that as well. So, okay, let's move on. So the part two. So about plastic limit. So students conducted 2 trials and find that PL is 17.2% for the first trial and the PL is 17.8% for the second trial. What is the PI of the soil? You use an average value of PL from the 2 plastic limit test. So it's pretty easy. So it's pretty standard that you do 2 trials for your plastic limit test. So you have a 17.2, you have a 17.8. You do the average. So the average of your PL will be 17.5, I think, right? So 17.5 is going to be your PL. And what about the PI? Well, the PI is the difference between PL and LL, right? So if you come back to this, our LL is 39.5. So the difference, the PI is basically 39.5 minus 17.5. You're going to have a 22 of PI. So your PI is going to be 22. Well, you can do the liquidity index. Again, this is a pure practice with our PL, LL, and this 21%. You can easily plug in all those numbers into this equation over here. Your omega is that 21%, your PL is 17.5, your LL is 39.5, and your PL is 17.5. So plug that in, and you can come up with the LI number. So let's go to the third part, or part 4, actually. Is this soil above A line or not? Okay, so with all those information, let's go back to the A line. So if you look at the A line is a little bit tricky. That is, x-axis is a fine, it's a liquid limit. That's something we can directly get from the testing. But make sure when you read from the top, it's very interesting that we're talking about PI. It's a plasticity index, not LL, is PI. So for the soil we just looked at, our liquid limit is 39.5. So we're looking at a 39.5 over here almost 40, and our plasticity index is about 22. So 22 is not 17.5, it's 22. So 22 somewhere over here, you draw a horizontal line, and then you draw a vertical line out of this 39.5 over here. Clearly, it falls into this region, clearly above the A line. So it's definitely going to be some sort of clay. And if you look at this legend, it's pretty hard to see, but it's looks like it's some inorganic clays of medium plasticity, so falling into this zone over here. So yeah, that's pretty much about it for. Oh, we have one more thing. So this is a report, a screenshot of a report for adderable limit test from the geotechnical investigation report we used for the first lab, and for the same project that happened in Chesapeake, Virginia. And I sent this to the lab and requested adderable limit, just kind of give you an idea of what it looks like. So yeah, basically this is what it looks like. That you have the sample ID, came from which borehole. Came from borehole number 2, and has the depths. The lab will give you the natural moisture content in percentage. So that's the omega we're talking about over here. And they did a testing for liquid limit 20, plastic limit 13, so LL and PL. And of course, the difference between the LL and PL, 20, 13, is going to be 7. And also, you can use the 16, 20, and 13 to calculate the Li over here as well. And they also did the calculation, they did a soil classification to be a clay essent, a CSM, a dual symbol. We'll talk about all those dual symbol in the next chapter. And based on your liquid limit and your plasticity index 7 and 20, you can put your soil right over here. So yeah, nothing really fancy or anything, but hopefully, if you ever need to read something like this, you should know where they are. And yeah, so that's pretty much about it for the second half of the adderable limit test, or the all the plasticity. Kind of kept it really simple. Just again, some sort of review, and also want to make sure it'll be easier for you for the later soil classification. So that's it for today. Feel free to click on the next video for the Friday session. So I'm going to post that again as well, so that after you finish that, you can start on your homework. So thank you so much. So I will talk to you in the next one.